Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue my series on adapting the fighting fantasy rules to a Twine game, using the Sword and Planet subgenre of science fiction to inspire the setting and plot. In the last video, I showed how I have set up the program so that it will simulate several runs through the game and keep track of how often each character dies or makes it through, or at least makes it to a point that I haven't yet written. And that has obvious uses in terms of adjusting the game balance, both overall, making it harder or easier overall, and also adjusting the balance between different characters. If it turns out that particular characters consistently do better or worse than others, we would probably want to change things to make it a bit more even. Another use of automated testing is that we're probably going to want to know where players are likely to go, which sections are they likely to see and which sections are they likely to not see, because we probably have some sections that we think, well, I want this to be a sort of a little side bit of the game. I want people to maybe see this one time in 20 or one time in 10 or something like that. And there are other parts that are perhaps we think are important to the plot, or we just think that they're quite well written. They're the sort of best bits, and we probably want the players to go through those bits every time, or at least most times. And so it would be useful to get a breakdown of where players are ending up as well. And that's what I've added to the program since the last video. So here we are at the beginning screen where we can play the game. We can have a one-off test, which isn't something we'd be doing very often. That was just done to make sure that the testing algorithm is working properly. And we can have a multi-game test. Obviously, when we have a finished game and release it, we won't have this screen and won't have these three options. We'll just go straight through to the playing, because the testing stuff is not sort of for the public. It's for us, the creator of the game, to sort of see if the game is turning out the way that we want, and to allow us to make changes if it isn't. So let's click on that. We should see. Oh, that was actually quicker than I thought, but often there's a few seconds of waiting time, because remember that I'm currently making it do 50 runs per character, and because there's 4 characters, that's 200 simulated plays of the game, including combat, etc. So obviously that's going to take a little bit of time. And if we wanted to, we could go through each of these run-throughs just to make sure that the program was working properly. But the core of what we want is probably right at the end, right down the bottom, where we have, there we go, we have these summaries where now we've already seen this part where it says how often each character died. This time it's saying that the first 3 characters didn't die at all, and character 4 died twice. So that might be, I mean, it's not that different, but that might be a concern if we kept getting that result, that character 4 is dying too often, or more often than the other characters. We might see that as a balance problem, and we might want to correct that. And also, of course, we might think that the numbers are too low in general. We might have the idea that, well, the amount of game that we've got so far, at least sort of some of them, they should be dying, some of the time, sort of thing. Or we might not. There's not an absolute objective answer to that. It just depends on how deadly we want the game to be. The deadlier it is, the more frustrating it is. But also perhaps if it's very easy, people will, that can be frustrating in a different way. It doesn't feel challenging, sort of thing. So there's not, as I say, there's not a sort of, I can't say, well, you want to set it up so that the player dies, 40% of the time or something like that. There's no obvious sort of answer to that. It's just something you have to find out by, hopefully, getting good feedback from human players, and also just your own experience. Because of course, if you are making a game like this, you probably play games like this, and so you probably have an idea of what makes for a good game like this. But at least we have the information. Of course, you might just say, well, we haven't done much of the game yet, so it's really very difficult to, difficult to say sort of what we want yet. We'll just make more and see. But anyway, the point is that we have this new thing where we have a breakdown of where each character ended up. So these little strings of characters, of letters and numbers, are the names of sections. It doesn't really matter what you name your sections, because the player never sees those names. It's only used internally, and so people will only see it if they actually get into the program. You may prefer to use numbers or some sort of, I use a pretty ad hoc system, I guess. Some people might prefer a more formal system where you have maybe a section and then you have a number, or you have something like the way that editions of software often work. So they will often have like release 1 and release 2 and release 3, but then they'll have, if they do a release after release 3, they might have 3.1 to indicate that, yes, it's different to release 3, but not that different. And then you might have sort of sub 3.1.1 and so on. Or you might prefer more descriptive names, like if they're in the city, you might have city 1, city 2, city thieves, meaning that's the section in the city where you meet up with some thieves, etc., etc., and because you find that easier to remember what's happening. This is just the way that I prefer. I'm not saying this is sort of how people should do it. But it tells us, for example, that character 1 ended up at 1 ALB 8 times, whereas character 2 ended up there 5 times, character 3 9 times, and character 4 also ended up there 9 times. So there's a slight difference there. We might, we might want to test further to see whether that keeps happening, and then we might want to think about why why one character tends to end up there and another one doesn't. If we look at this, we can see that 1 ALC is very much sort of more common than any of the others. We can see that that's true for character 2, though to a far lesser extent, it seems. Well, we've got 1 ALE kind of... Actually, it's not that different, is it? This one's less... we're not seeing that pattern for character 3. And then... for character 3 and 4, we're seeing that they end up at 1 ALC and 1 ALE, sort of closer to the same amount of times. Now, of course, because I'm using a sort of non-descriptive system, just a sort of ad hoc system, just really making it up as I go, that doesn't tell me much about... I can't remember off the top of my head what those are. So we probably want to look within the program, and specifically in the initialize section, and specifically the bit where we set up this big S array. We might want to see what they are. And we will see, for example, that... Where is it? One ALC is... Oh, okay. It's actually... it actually looks like it probably is just random differences, because one ALA, B, C, D, and E are random encounters within the forest, and C is the one where you... well, it will be the one where you come across the third species that's on the planet that we haven't yet met, haven't done anything about. And one ALE is a similar one, is another encounter that we haven't written. So we would probably conclude from that it's just random chance, because whether you go to one of those or the other is just basically the roll of a die. And so if we reran this, we probably wouldn't see a consistent pattern that one character's ending up, in one place more than another. But a more substantial difference might be, I know that M is the one, all of the ones that begin with M are the ones where you end up in the city. So we can see that that character 1 ended up in the city 6 times. This one 11 times, which is significantly more. This one only 6 times. I always keep counting that one as 2. Like if it ends in a number, I always miscount it as being twice. So beware of that if you're using a similar system. And this guy only 3 times. So that's quite a difference, and we might want to check that. We might want to run it again and see whether that indicates that. See whether there's some reason why a particular character would be more likely to end up, in the city if we keep getting those results. And of course, as always, we might just conclude that, we don't really know enough about sort of, we haven't written enough of the game to kind of get a strong picture, and we might just want to write more and see what happens. But it does give us an idea. It does tell us that characters are ending up quite strongly in this, in the forest bit, and that's not in objectively good news or bad news. That's the bit where you leave the gorilla-like aliens, or either you choose to leave them or they force you to leave, and you are wandering through the forest, and you hope to get to the good city, or the relatively good city, where you will meet your true love. And that's not, as I say, the fact that they're ending up there is not good or bad. It's just whether that fits with our idea for the game. And did we think that, we want most characters, there's a few side things that can happen, but we probably want most characters to be going through the forest and then end up in the city and then meet and then meet their true love. And if that's what we want, well, it seems like that's roughly what we're getting. Or we might say, well, actually, no, I don't want them to end up at the city straight away. We thought maybe some of them would, but I mostly wanted them to end up interacting with the insects, for example, which we haven't, as I say, we haven't written yet. I want them to sort of face more difficulties before they end up with the city. I wanted the city to be sort of the end of the story, and it seems like they're getting there quite quickly and quite easily without dying. And I kind of thought of it as being the end of your quest. You sort of finally fight your way through to the city, and the end of the game can begin. And so if that's the model that we have, well, then that would be a problem, and then that would indicate that we want to make it more difficult to get to the city. Or, of course, we might conclude that we want them to get to the city more often than is happening. You know, I don't have as strong an idea of the flow of the game, I guess. At the moment, I'm quite happy to just add to it and sort of see what happens, and then think about what I think is the most interesting bits of the game, and then try and sort of funnel or set it up. Yeah, well, funnel characters, I suppose, as long as they still have a choice. Funnel it so that most of the time they'll perhaps go through the bits that I consider the best, and you know, that they'll end up with the bits that I think are maybe less interesting less often. But that's the approach that I take towards writing these games. You know, I sort of almost take an improvising approach. I like to write an encounter and kind of think of ideas for it as I'm writing it, and change ideas and go, oh, well, that could lead to this, or you could get something from them which, you know, then becomes useful over here, or something like that. Other people might take a more planned approach, and obviously if you're taking a more planned approach, these kind of statistics will be more useful for you. Anyway, now that we've got those statistics, I'm going to spend the rest of the video showing you how I made them. So we will mostly be looking at multi and at this new page called Count Repetitions. And we will look a little bit at the initialize page, which is the start of the program, because that's where we set up a couple of new variables that we need. Actually, a single new variable that we need. The actual business of running through each run of the game happens in these pages, but I haven't changed anything since the last video about how they work, so we won't be looking at those. All right, so let's look at initialize. The only thing we need to look at is the F array. F perhaps standing for finished, I don't know. So we have set F, or set $F equals and a set of square brackets. So we're setting it up as an array. And then we have a comment, which I'll come back to. Then we have a for loop, which goes from 1 to 4, because that's the number of characters. By the way, I am doing a bad programming practice here. Instead of going from 1 to 4, what I should do is I should have a variable which is the number of characters. And then every time I'm dealing with the number of characters, so for example, when I set CH to a random value between 1 and 4, it should be, instead of a number, it should be random bracket 1 comma the variable, end bracket. And the reason that would be a better practice is that if I change the characters, let's say I add a 5th character, well, now I have to change it here to 5. I have to change this so that it goes up to 5, and there's a few other places where I have to change it as well. Whereas if I have a variable, I can just change that variable, and all of the other references will be to that variable, so they'll automatically use the right number. The reason that I haven't done it that way, even though that's a better way, is I've pretty much decided that I'm going to just have these 4 characters. But you know, honestly, it's probably not a great practice. It's a bit sloppy. Anyway, so for example, this one goes from 1 to 4. This one also goes from 1 to 4, and there's a few others scattered throughout the game. And if I miss one, if I update the number of characters and I miss one of those references, well, the program won't quite work properly, and that might be a bit hard to notice. Because of course, if there's 5 characters, well, it's gonna choose one of the first 4 80% of the time if it has a random choice. So nothing will sort of leap out until I notice, oh gee, that one's not picking character 5 very often. Anyway. Be that as it may, I do have it in the bad way. So here's what we do. We go from 1 to 4 in a for loop. We set $f square bracket $z n square bracket to be itself an array. And then we set $f $z 0 to be 0. So let's look at this comment and see what we're doing here. fz1, fz2, etc. store which unwritten sections character z ended up at. fz0 stores how many times character z ended up at an unwritten section. So let's say we're dealing with character 2. $f20 might end up being, let's say, 47. If the character died 3 times, then they will have ended up at an unwritten section 47 times. And then F21, F22, F23, etc., all the way up to F247 will be just the names of the different sections that they ended up at. Initially, in the order in which they ended up in those sections. We then take that list and sort of change it round so that we can report on it in a little bit more useful a way, which I'll show you now. All right, so we have multi, and I've expanded the code which deals with updating the $D array. $D is an array that keeps track of how often each character died. So what happens is we have a loop that goes from 1 to 4. Another example of it should be a variable, but anyway. And then for each character, I've arbitrarily chosen 50 as the number of times that we're going to, the number of sort of games with that character that we're going to simulate. And in each of those, we generate a character, and then we do a one-off, or we do the same thing that we would be doing if we were doing a one-off test, which is dealt with in these 5 pages up here. And when that ends, one of two things, it will end either because the character that the simulated player has ended up at an unwritten section, or because they've died. And what I said before is if the 0th slot of the of $S $TZ being the section that you're in, if that does not equal unwritten, then we increment the relevant slot of $D, because if they haven't ended up in an unwritten section, then they've died. In the final game, there'll be some other options, because you can, well, firstly, you won't ever end up in an unwritten section if the game is finished, but secondly, the game can end without you dying, because of course we want the possibility that the player can win. And depending on how the plot turns out, there might be endings where you're considered to lose, but in the story you don't actually die. Because the goal is to marry this your true love, perhaps they die and you're heartbroken or something like that, and that's treated as a loss, but it doesn't end up with the death of the character. But for now, they either end up in an unwritten section or they die. So this bit was already there, but I've added this other bit. So basically, if the paragraph that you ended up at is an unwritten paragraph, then we do this, which is new, and if it's not, we increment D. So what do? We set $F, $TY, 0, ++. We add 1 to its value. So TY is the character that we're dealing with, and as we said in initialize, $F some number 0 stores how many times that particular character ended up at an unwritten section. In other words, how often they survived. So we increment that, and then I'm just going to sneeze, so just hold on a second. Oh, no, it's gone. Okay. All right, sorry. We increment this, and then we set the next slot in F to be equal to the paragraph that we ended up. So this looks a bit complicated, but I'll write it out to make it a bit easier. We've got $F, and then we've got two sets of brackets. One of them is TY, which is just the character that we're dealing with. And the other one is $F, $TY0. So this slot always starts with a value of 0. We set them all up with a value of 0 in initialize. So let's say we're incrementing it for the first time. Well, that will increment to 1. And so we will set $F TY1 to be equal to TZ. The next time we do this, this will increment to 2. And so we will set $F TY2 to be equal to whatever paragraph we ended up at. And so on. So all this line of, or this particular bit of the code here looks a bit complicated, but all it's saying is just fill in the next slot. We could probably do something with .length, which gave us the same result, but anyway, I've decided to do it this way. It's just saying fill in the next slot in this particular part of the array. And I've already shown you this code. That's just resetting the variables that need to be reset for the next run through. So what we end up with is a series of names of paragraphs, but they won't be in any particular order. The ones that are the same won't be grouped together. So, and as you saw in the display, it was grouping them together. It said things like 1AS times 5 or times 10 or whatever. So it told you how many times you ended up at particular ones. So how do we do that? Well, there's two parts to that. First of all, as the note says, we put the F array into alphabetical order. So that's this bit of code here. We have a loop that goes from 1 to 4, and then Z goes from 1 to $F TY0. So that's the slot that keeps track of how many. And note that it's under, not under or equal. And the reason for that is because we're comparing two slots. Z, which goes from 1 to 1 less than this value, and then Y goes from Z plus 1. Sorry, I didn't highlight that properly. Y goes from Z plus 1 to $F TY0, i.e. it is under or equal. And you'll often see this sort of structure when you want to compare every pair of slots in an array. So let's say there's 10 slots in an array. Z will go from 1, 2, 3, 4, 5, 6, 7, 8, and 9, but it won't do 10 because it only continues while it's less than this number. And then Y, when Z is 1, Y will go from 2 to 10. When Z is 2, Y will go from 3 to 10. When Z is 3, Y will go from 4 to 10, and so on and so on, up to 9, where it will only go to 10. So that will end up with every pair being compared. So how do we compare them? Well, we compare their alphabetical order. And you can compare text just as you would compare numbers. I can say, as I've said here, if $F TYZ is greater than $F TYY, and it doesn't go, well, wait a minute, what do you mean it's one greater than the other? They're not numbers. Neither of them has a numerical value. it will compare these, and it's fine with comparing text. If that's the case, then it will swap the two. So we do that. You swap two variables by passing the value of one through a third variable. So we set x equal to ftyz, we set ftyz equal to ftyy, and then we set ftyy equal to x. So we store the value of one of them in a third variable. We overwrite that value with the value of the other one, if that makes sense. So let's say we want to swap a and b. The way that you'd swap the values of a and b is and it doesn't matter in this case I'm setting x equal to a, but I could do it equally with setting x equal to b. But we set x equal to a, then we set a equal to b, and then we set b equal to x, and that will end up with a having the value that b used to have and b having the value that a used to have. You need to use this third variable because if you say set a equals b, you've now lost the old value of a, and similarly if you say set b equals a, you've lost the old value of b. So you need to store that in a third variable, and you need that third variable to be a temporary variable. It needs to not matter what value x has. So we swap the two if the zth one is over the yth one, and that puts them in an order. Now, having grouped them all together, having grouped the same results together, we then display the results. But we don't want to display, let's say 1ax is the result. We don't want to say 1ax, 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 1ax. We want to say 1ax times 5, for example. And this is how we do that. We do this in this count repetitions page. So here's how we do it. We set ty equal to 1, ty is less than or equal to 4. Again, this is going through all the characters. We've already, this is what we had in the last video. We say character ty died $d ty times. So character 3 died 0 times, or character 3 died 2 times, or whatever it may be. Then we print the results for character ty. So we have a loop that goes from 1 to fty0, i.e. the number of times they ended up at an unwritten paragraph. And then we do one of two things. Let's look at the easier one first. If ftyz is equal to ftyz plus 1, then we do this. If they're not equal, in other words, if we come to a list, we come to one, we've got this list and it's 1ax, 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 1ax2. All right, let's say 1ax2 and then 1ax3. Okay, so they've only been to 1ax2 once. So we just print that and a line break. So that's very straightforward. That's for ones that they only ended up at one time. It's more complicated when we have a result that they ended up at more than once. So what do we do there? Well, we set y equals 2. Y is the number of times that result appears, and we have to find out. We know that it's at least 2 because this slot is equal to this slot, so there's at least 2 times that it repeats. But we have to actually count how often it repeats, and then we have to print the result times however many times it repeats, and then we have to increase the value of z, because let's say we've got 1ax 7 times. We want to say 1ax times 7, but we don't want to then go to the next slot, which is also 1ax. We want to skip over all of those 6 and go to the next one that's different. So let's see how that works. We have this comparison. If fty z plus y, so z is the slot that we're currently on, y is the number of repetitions we know that there is. If that one we add the number of repetitions to the current slot. If that is also equal to the one we're looking at, then we increment y again and include count repetitions, i.e. we go up to the top of the page. If not, once we find one that's different, either because there's a new entry or because we've come to the end of the list, then we print the slot times the number of repetitions we've discovered, and then we increment z by the number of repetitions minus 1. So that's a bit mathy and unintuitive, so let's look at an example. Let's say slot 1 is 1AX, slot 2 is 1AX, slot 3 is 1AX, and slot 4 is 1AY. And we start at slot 1, and on the previous page we say, does slot TYZ equals slot TYZ plus 1? Well, the answer is yes. So we set y equals 2 and go to count repetition. So we've asked ourselves, does this slot equal this slot? Yes, it does. Okay, we'll set what? Well, that means we know there's at least 2 repetitions. So we set y equals 2. We go here. We say, does slot z plus 2 equals slot TYZ? In other words, does slot 1 does slot 3 equal slot 1? Yep. Okay, so we'll increase the repetitions to 3. We go to count repetitions. Does slot 1 plus 3 equals slot 1? No, it doesn't. Okay, so we'll print slot 1 times 3. Then we increase z by y minus 1. So there's 3 repetitions. So we increase it by 2, and that seems wrong. It says, well, hang on, don't we want to increase it to there? No, we want to increase it to there, and I'll show you why. We increase it to 3. But remember, that's the end of the for loop, and because it's the end of the for loop, it'll increase z to 4. So it sort of seems like we're going, in this one, it sort of seems like we're going to the wrong slot. It seems like we should go here. But if we went here, it would then increase to 5. So we increase it to sort of 1 less than we want, and then the for loop ends, and it increments to the one we want. So that's a bit complicated, and it's a bit complicated, and it doesn't sort of, to me, it doesn't make intuitive sense, but that it does work. And if we count, we can see that it works, because if we count the number of results, they will add up to 50. If we count the number of times the character dies, and then count all of the paragraphs that are reported that the character ended up at without dying, that will always add up to 50, and that's the result we want, because we know that we're sending each character through 50 times, and that is how we get information about where the players are ending up. There is other stuff that we could find from automatic testing. We could find how often they're going through particular paragraphs. For example, we could set a paragraph and say how many times out of 50 or whatever one we want, how often does the character end up hitting this paragraph? At least once, or and that might be relevant if we want that particular paragraph to be rare or common, and we're suspecting that it isn't doing what we want in our own runs through the game. But for the immediate future, I think I'm going to actually just concentrate on writing more of the game and then talking about that. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.